Okay, Assalamualaikum class. So this is last part of chapter 2. So you will learn in this chapter about period parallel and current divider. So as we recall back in previous video, you learn about series circuit, right? Series circuit. So your R equivalent is equal to, let's say there are two resistors, and this we are going to apply the voltage divider. But for the parallel circuit, it is for current divider. Okay, now let's see how the parallel circuit looks like. So what is the concept of parallel? We have two nodes at num1 and 2. So both resistors, let's say here is R1 and R2, must sharing the same nodes at both nodes, the first and the second nodes. So if we see here, there is a node A and node B, and we have three branch, and this node A and node B are sharing together, right? So we can say your R1 is actually parallel to R2. So now let's derive what is the equivalent resistance for parallel circuits. Okay, so let me change the pen. Okay, so as usual, we apply Ohm's law. So we look at the voltage drop at this V here. So let's say we denote here as V. V is equal, V is equal to I1 R1. Okay, so in a series circuit just now, your current will be the same, right? But in your parallel, what will be the same? Voltage will be the same. Okay, so since they are sharing the same node, so let's say you have V1 here, and then here is V2. So you can denote V1 is equal to V2 is actually equal to V. So let's say here is V1 and here is V2, I2, R2. Okay. So actually your V1 is actually equal to V2, and you can denote this one as V only. So V is equal to I1 R1, and it also equal to I2 R2. Okay. So far, can you follow? Why? Because the voltage are the same when they are parallel. Okay. So now, once you got this equation, now let's move to the current. So let me change the pen. So, okay. So you see here, the total current is I, and then it start to branch out, right? I1 and I2. So by using KCL concept, current entering to this node A, so for example, we define this as A, is equal to the current leaving. So current leaving is I1 plus I2. Okay. So this is the concept of KCL. Current entering is equal current leaving. So you know I, so there's no one here. I is equal to I1 plus I2. But what is I1? So go back to this equation. I1 is equal V over R1 plus V over R2. So you can get the total I is actually V over R1 plus V over R2. So let's try to simplify this equation. So you take out your V, it become 1 over R1 plus 1 over R2. So this is actually V over R equivalent. Okay. So remember our aim, we want to find the equivalent, right? So what is 1 over R equivalent here? If you cancel this one, so you can get the equation 1 over R equivalent is actually 1 over R1 plus 1 over R2. So this is how you get the equivalent of the parallel circuits. So if you have three parallel, it will continue 1 over R1 plus 1 over R2 plus 1 over R3. Or if there is only two, we can simplify this equation, become R1, R2 divided by R1 plus R2. So this is how you get the equivalent resistance for the parallel circuits. Okay. So the equivalent resistance of two parallel circuits, this only apply if you have only two in parallel, R1 and R2. You can use this equation. So your R equivalent is actually R1 R2 divided by R1 plus R2. But if you have three, you have R1 and then you have R2 and then you have R3, you cannot use this equation. So what is the equivalent? Go back to the basic equation. 1 over R equivalent plus 1 over R1 plus 1 over R2 plus 1 over R3. So this is how you get the equivalent resistance in parallel. So from that parallel, it will lead to the current division. If you remember just now, series will lead to the voltage division, right? So now current division only can apply at the parallel circuits where there will be the maximum only two parallel. If there are three parallel, you cannot apply current division. So what is actually current division? Okay, let's derive it again. So you know the voltage are the same, right? If this is one is V, this one also V, and this one is also V because they are in parallel. So you can get V equal I1 R1 is equal to I2 R2. So you know V is equal I R equivalent. Okay. So in your current division, your aim now is to find current. That's why the name is current, right? So we want to know, this is our aim. You want to know the value of I1 and I2. Remember just now in series, you want to know what is the value of V1 and V2, right? Same here. I1 is equal to what? So I1 is equal to the opposite resistance. It's not the same. It's the opposite resistance, that is R2. Divide by what? Divide by the total resistance. Okay. Multiply by the total current. So this is the keyword here. When you want to find I1, the above one must be opposite or opposite. Okay. Okay. Next, how you're going to find I2? So what is I2? I2 again is the opposite resistance. What is the opposite? R1 divided by R total, R1 plus R2 multiplied by total current. Multiply by total current. So actually this formula is coming from here. So and then you can derive accordingly. Okay. But this is what you're going to hold. How you find current division? I1 is opposite R2 divided by total, not multiplied by total current. And I2 is opposite resistance, that is R1 divided by the total resistance multiplied by the total current. So that's how you get the current division. Okay, so we see more example in our class. Okay, last part, conductance. So what is conductance? The ability to conduct current, right? So actually G is actually inversely proportional to R. So let's say R is 1 kilo ohm. What is G? G is 1 over 1K. And then you can get 1 milli Siemens. It's the inverse. Okay. So you know, for resistors, if it is in series, you just add, right? R1 plus R2 plus dot dot. But if it is in parallel, you're going to have 1 over R equivalent is 1 over R1 plus 1 over R2, blah, 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 blah. But how about conductance? So conductance will be opposite. So if it is in series, you need to use the parallel equation. If it is in parallel, you need to use the series equation. Why? Because conductance is inversely proportional to the resistance. Okay. So let's see one example for this video. Okay. So now you need to find R equivalent. So you need to be clear what is the concept of parallel, what is the concept of series. So now how you're going to solve? You need to start from the other end. So this is the end, right? So now look at 4 and 5. Are they series or parallel? So 4 and 5 are series because they are sharing the same node. So you can have 4 plus 5 equal to 9. So you're going to simplify the circuit. So it becomes, this is 4, this is 3, this is 3, and then this is 4. And then what happened? 4, 5, and 3, are they in series? Yes, because they are sharing only one node. So become 9, 12. So become 12. Okay. So now look at 4 and 12. Are they series and or parallel? So you can say 4 parallel to 12. So it become left one element here. So now this is 3, this is 6, right? 6, 6, 4, and 3. Okay, so how you going to get for parallel 2? So you just use this formula, 4 plus 12, and then you can get 3. So now let's continue. So now this become 3, right? So then 3 and 3, are they series or parallel? 3 and 3 series, right? So you can just 3 plus 3 becomes 6. And then here is also 6. And then you get 3 here and 3. So now 6 and 6, they are parallel, right? So you can combine 6. This is parallel. This is 3 and this is also 3, and you look from here. So now what is 6 times 6? 6 plus 6, so you can get 3. 36 is 3, right? So what is the final equivalent? So now look at 3, 3, and 3. They are sharing only one nodes together. So you can say R equivalent equal. Okay, sorry, this is not 3. This is 4, right? Okay, this is 4. Okay, and then here you can get R equivalent. So what is R equivalent? 4 is in series with this 3 and also in series with this 3, and then you can get 10 ohm. Okay, so what is the tips? Slowly, when the question asks R equivalent, start from one end, the other end, and then slowly move towards the right until you reach this R equivalent. Okay, so we see more example after this, and that's all for this video today. See you in the class. Assalamualaikum.